Question. Assalamualaikum doktor. Saya nak tanya, untuk second order, macam mana nak dapat nilai yang saya tanda dekat atas tu? Effective depth ratio dengan nilai ES. Alright, effective depth ratio dan juga ES di sini. Answer, jawapan. For slender column, second order moment is calculated using this formula. And this E2 is determined using this equation. And this curvature is determined using this equation, equal to and this is a factor for taking account of creep. Okay, and this equation, this value is determined using this equation. One plus beta multiplied with the effective depth ratio must less or equal to 1. And this effective creep ratio is determined using this equation. And question asked by your friend is how to get this final creep coefficient according to 3.1.4. And let's go to the clause 3.1.4 in Eurocode 1992, part 1.1. Okay, clause 3.1.4 from Eurocode 1992, part 1.1. And this is creep and shrinkage. Let's go to this figure. Alright. So this is figure to determine final creep coefficient. So in this clause, there are two sections. First is this figure is divided into two sections. First is the concrete inside condition, where the relative humidity is equal to 50%. And the second one is outside condition, where the relative humidity is 80%. Okay, so in the question, the column is at the outside condition. Thus, we refer to this figure. I will show you how to use this figure. First, you need to start with this right graph, then followed with this left graph, and the objective is to get answer from this x-axis. Okay, from this graph, you need to start with this HO. This HO is the notional size, which is equal to 2AC divided by U. Okay, and also you can find this equation in the next page. So this is the notional size, equal to 2AC divided by U, where AC is the concrete cross-sectional area and the U is the perimeter of the part which is exposed to drying. And this is, in your case, 4 column, which is constructed outside and exposed to the environment. Okay, so the AC is the cross-sectional. So this is the cross-sectional for the concrete. Okay. Alright, B and H. And the U is the parameter of that part which is exposed to drying. Okay, so this is the parameter from this plus this one plus at the back meter and at this side. Okay, all this parameter, okay, is U. Okay, you calculate the notional size Okay, let's say the answer is 900. Okay, and draw a straight line upwards and stop at the concrete strength for your design. For example, stop at 30. Okay, so 30 here, and when you stop here, this is 30, stop here and draw straight line to the left graph and stop at S and OR. And what is S and R? Okay, S and R is the classes of cement. Okay, R is early strength gain. Strength gain. Meanwhile, for N is normal strength gain. And the last one is L. Okay, LOS. Okay, LOS, okay, is the cement class for low and or slow strength gain. Okay, so in this case, when you design a column, strength 28 days, we select the early strength gain. Okay, so we select R. Okay, then you stop at R and draw a straight line downwards, and this is the point for the final creep coefficient. So I hope this answers your question. And the details is we use the outside condition for the column for your case, and the relative humidity is 80%, and the age, okay, the age is 30 days. Okay, so concrete used for this example for your question is 25 Newton per millimeter square, grade 25. So we use H days, 30 days. Okay, so 30 days, and the class is R. And the next question, so this answer your question how to get the creep, final creep coefficient. Okay, final creep coefficient. Okay, the next question is, okay, how to assume the moment here, all right, due to the quasi-permanent load over a moment due to the ultimate load. Okay, so here is 0.67 assume. It is, I have no direct answer for this one because the quasi-load, it depends on the combination of the load used, okay, for the design. Okay, but basically we take the assumption in the range between 0.6, okay, to 0.7. Okay, for this M due to the quasi-loading to ratio of the M due to the quasi-loading over the M due to the ultimate loading. Okay, so we assume range between 0.6 to 0.7, and this is ES. So the ES here is the Young modulus force tail, and Young modulus force tail range between 205, okay, megapascal to 215 megapascal. All right, and here is the D. The next question is how to calculate the effective depth ratio for this case. So this one is similar with other structural element. So the D, we know that the D, let me do like this. Okay, so this is the cross section for a column. And here is the reinforcement. And you need to provide shear link for reinforcement arrangement. Okay, so this shear link is with certain diameter. Okay, so I just draw it like this. Alright, so to calculate the depth of effective depth for the column, alright, which color I want to use. So this one here is H. The total depth is H from this point to this point, and for the D, at the center of this bottom reinforcement to the top surface. Okay, so here this diameter is at the center, so you need H minus half of this, which is diameter, the main reinforcement divided by 2, minus the shear link here, okay, and minus the C nominal here. And this is how to calculate effective depth for column. So I hope I have answered all the question from you, okay, my student from BFC 34803 concrete structural design. Okay, thank you.